Hello everyone, we are Team Nitrogen and today we will present our STEM project, a fall collector designed to help address the water scarcity problem in Monterrey. In recent years, the city has faced serious water shortage with dams such as La Boca and Cerro Prieto reaching critically low levels according to Economista 2023. These reservoirs dropped to minimum capacity, causing cuts, rationing, and major disruptions in daily life. Because of this situation, we focused on developing a low-cost and environmental friendly system capable of collecting small amounts of water directly from the air. Our proposal aligns with several nations' sustainable development goals, including SDG 6, water, clean water and sanitation, SDG 9, industry innovation and infrastructure, and SDG 13, climate action. These goals inspired us to create a solution that promotes sustainability, innovation, and community resilience.
Thank you. I will explain the scientific foundation behind our project. The fall collector works through condensation, which is the process where the water vapor turns into liquid water when it touches a cooler surface. This transformation can be represented by the equation H2O in gaseous state to H2O in liquid. The main substances involved are water vapor, naturally present in the air, liquid water formed after condensation, atmospheric gases like nitrogen and oxygen, and aluminum, which we selected because it cools quickly and allows droplets to form and slide efficiently. Our design is supported by the scientific research. For example, El Shenawi demonstrated that aluminum meshes with optimized geometry significantly improve fog harvesting performance. Similarly, Nickback and Hayhat showed that metal mesh structures can successfully collect water even in dry environments with moderate humidity. These findings guided our decisions regarding materials and structure.
Now I will describe how our prototype works. Our fall collector consists of a vertical aluminum mesh mounted on a lightweight frame. Behind it, we added a layer of shade cloth to prevent the surface from overheating, especially during the daytime. At the bottom, there is a PVC gutter that directs the condensed water into the storage container. When humid air passes through the mesh, droplets form on the cold aluminum surface, and these droplets slide downward due to gravity, accumulating the water, and finally flow into the container. From the engineering perspective, the system must be stable, properly angled, and placed in an area with good airflow. Another advantage is that the prototype does not require electricity, making it ideal for school, communities, and low-resource environments. The estimated cost of our prototype is between 350 and 500 pesos, which makes accessible, low maintenance, and easy to implement.
Table of variables, we use the amount of water collected, the milliliter per day, a measuring cup, / test tube, and the expected result is 100 to 300 milliliters. We use ambient temperature with Celsius and a digital thermometer, and the expected result is 20 to 35 Celsius. We use relative humidity with percentage and a high hygrometer, and we expect a 30 to 70% result. And we use exposure time with hours and stopwatch, and we expect 8 to 12 night hours.
To conclude our presentation, our thesis states that the fog collector is capable of capturing between 100 and 300 milliliters of fog water using efficient aluminum mesh. This water can be used for watering plants, cleaning, or washing utensils, helping reduce the effects of Monterrey's water crisis. Our results and scientific sources confirm that the thesis is valid and can be defended, since fog collectors have proven to be real, functional, and sustainable systems in many regions around the world. This project is strongly connected to the STEM areas in science. We apply concepts such as condensation, humidity, and material behavior. In technology, we use tools and simple mechanisms to improve water capture. In engineering, we design and build a working prototype capable of withstanding environmental conditions. In mathematics, we calculate surface area, measure variables, and analyze data to predict performance. In summary, although the fog collector does not solve the entire water crisis, it represents an innovative, low-cost, and environmentally friendly option that encourage sustainable thinking and demonstrate that how STEM can be used to address real-world problems. Thank you very much for listening.